when we see about TS, TS means time period for the transmission of one signal element. That is TS. So in one signal, bits are transferred. So that TS, time required for the transmission of one signal element, is represented by LT. L means how many number of bits are transmitted in one signal, and T means time required for the one bit transmission. Bit period is T. So LT is equal to TS. For example, for the one bit, it's 10 millisecond is needed. And if we are transferring 2 bits using one signal element, then TS will be 20 milliseconds. And total bandwidth required is 2 MFD. As I have already mentioned, M means different signal elements. If we are transferring 2 bits using one signal element, then 4 different combinations are possible. So we have 4 different elements, 4 different signal elements. So if we have 4 different signal elements, if it's FC, then this will be FD. But as I have already mentioned, it should be equal and opposite amount from the Harrier frequency. So the next opposite data will be another FD. So the total deviation is 2FD. So if you are using 4 different signal elements, then it will be multiplied by according to its M. So the total bandwidth required becomes 2 MFD. If it's 8, then it will go on 8 like that. Minimum frequency separation required is 2FD because it's FC2 here FD and another representation should be equal and opposite amount from the FC. So the total deviation is 2FD. And the 2FD is equal to 1 over TS. TS means time required for the transmission of one signal element. We know the equation F is equal to 1 over T. So 1 over TS means Fs, frequency of the signal element. So the separation between two signal elements should be enough for the transmission of one signal. So to FD, the separation should be enough to transfer the frequency of the signal. Then only it can able to transfer the data. So the minimum separation to FD should be equal to 1 over TS. Total bandwidth, that is also called as WD, denoted by, and as we have already seen, that is 2MFD, and if we substitute 2FD by TS, then it's also give us the formula M over TS. If we have seen one of the example, the question refers FC is equal to 250 Hertz, FD 25 Hertz, M is 8. That means one signal is represented by 3 bits. That's why 2 to the power of L, 2 to the power of 3, 8 different signal is possible. So 8 possible 3-bit data combination. Here we have taken FC as 250 Hertz. So, one should be 275. Another one should be 225. Because here FD is given as 25 Hertz. So, 250 minus 25, 225. And another one should be equal and opposite from the FC. So 275. So here the minimum separation between two signal elements is 50 Hertz. So the minimum separation is 50 Hertz. So next one should be 175 Hertz. Here the difference is 75 Hertz. So in the opposite amount also, 250 plus 75, 325. And here the difference, 275, 325, 50 Hertz. So the next one is represented by 375. Like that, we have found 8 different frequencies. But to find the frequencies, we have the formula. Fi is equal to Fc plus 2I minus 1 minus M into Fd. In the question, Fc is 250, 2I, 2 into 1 minus 1, 1 minus M, 8, so 7, 7 Fd, minus 7 Fd. So, minus 7 into 25 Hertz, that is minus 175 Hertz. So, Fc is 250. 250 minus 175, that is equal to 75. So the first one is 75. In this similar way, if we have put the equation for every f, for every I, we can find these 8 different frequencies. And the scheme can support a data rate of 1 over T. T means we have already seen that is bit rate. So 1 over T is data rate. As I have already mentioned, the minimum frequency difference, that is 2FD, should be equal to the frequency of the signal element, Fs, that is 1 by Ts. Ts is time required for the transferring of one signal element. And Ts is equal to L into T. L means number of bits representing and T means bit rate. So here we have made 1 by T as the subject. So equation is equal to 2LFG. And in this question, it is 150 kilobits per second.